So how to get the thin uniformly charged disk? You take some paper, thin wooden circular disk or thin paper or thin plastic disc. You deposit charge, you take some charged liquid, take a brush and paint it uniformly. The charge will get deposited only on one surface. Then it will become a uniformly thin charged disk. Okay, carry on. No. So what is the elemental structure you are supposed to assume here? The ring, the elemental structure is what, the ring is what we are going to assume. What is the charge? The charge is what I have to show here. What is it? Then we'll define here uniform charge density. Sigma will define it. What is the sigma? Surface charge density. Only on one face the charge will be there, not on two faces. Bread, you apply jam only on one face of the bread. That's all over. Total charge on it will be Q, that one, let R be the radius. No, on the axis you have to determine the field strength. So I'll start with let me assume a ring of radius R and thickness dr. I think this also we have done in gravitation chapter. Even this also completed in gravitation chapter. Thick arrow. Thickness of this, let it be dr. The width, sorry, the width, and let this be smaller. Radius of this is capital R, or yeah, capital R, let it be. Then how much of charge present on the ring? dq charge. Total charge on the disk, let it be capital Q. How much of charge present? Elemental ring it is. This is a disk. What is this? Charge on elemental ring. Shall we write sigma into what is the area of the ring? dA. Sigma, what is dA? 2 pi r dr. What do you mean by area? The green color one. The area of the strip. Better. Like what is the ring? Ring of radius r and width dr. I think this dr is not thickness. Dr is not thickness. Dr what we should call the width of the ring. Technical terms, please do notice dr is width of ring. Okay, let's get into this one. So what is the field strength at point P due to this elemental ring? dE should be equal to field due to elemental ring. dE should be equal to what is the formula? K dq r by r square plus small r square plus x square to the power of 3 by 2. From where I am bringing this, what is the radius of this green color ring? Small r. And what is the field strength on the axis of that ring? This should be formula. Why smaller? Go back. Just now we derived. This is what? Yeah, x. No, it should be, sorry. KQX it is. Now what to do, how to integrate? Somebody should help us, no, here. How to manage that integration. So let me take help of the geometry available here. So this is the this is theta. So call this is say some we have took all almost all symbol, no? Some SS, let me write it. Tan theta, what we can write? R by X. Look at some triangle. So where's the triangle? I'm asking you to look at this triangle. Tan theta equal to R by X. Then R equal to, so can you replace X or R? I think better to replace R. R equal to X tan theta. Then we'll simplify all the things. So what should be the condition? No? Let tan theta equal to R by X. Fine. So let's get into simplification part. D equal to K. What is dq? Sigma 2 pi R dr into X. Take help of this substitution. R equal to X tan theta. Dr is needed. R equal to X tan theta. Dr should be replaced. Dr is equal to X secant square theta d theta. Let me substitute all the quantities. D equal to 2 pi sigma K. Let it be outside. What is R is equal to? X tan theta. Dr is X secant square theta d theta. X, let it be as it is. All divided by R. R will be X tan theta whole square. X squared to the power of 3 by 2. 2 pi sigma K X cube tan theta secant square theta d theta. Here X square, 1 X cube will come outside. So tan square theta plus 1 to the power of 3 by 2. X cube get cancelled. So 2 pi sigma K. Tan theta will be sin theta by cos theta. Or one more step. Tan theta secant square theta d theta. 1 plus tan square theta secant square theta. So secant cube theta will be there. Please look at here. I'm replacing 1 plus tan square theta. I'll write one more step. What is this one? Secant square theta 3 by 2. So this will be 2 pi sigma K tan theta secant cube theta secant square by theta. So this will become secant theta d theta. So this will be only, I'll end up with this one. What should be the limit? So I'll integrate. Zero to R only. Later I'll bring it. It should be 0 to capital R only. So first we'll get expression 2 pi sigma K. This will be minus of cos theta. There's limits. The limit will be 0 to capital R. I'll bring it. And what is cos theta from the diagram? X by S. I have space. Yeah. I'll proceed like this. 2 pi sigma k cos theta will be minus of x by s root of, this will be r square plus x square. The limit should be 0 to capital R. Don't go for in terms of theta, let it be this one. Don't substitute any limit. Now you substitute the limit. So what is the resultant field will be? E is equal to 2 pi sigma k. First x equal to capital R. So minus R root of minus x by root of r square plus x square. Minus of minus, this will be smaller equal to, so this will be 1. So the final answer will be further k, what you can write 1 by 4 pi epsilon naught. So 2 pi get cancelled. So sigma by 2 epsilon naught. I think this formula what you have to remember. Many good questions will be there with SHM, other things. This is our final answer. You check the main sum 5 times they've asked. Any student remember this formula? Finish, or you can manage. Field on the axis of thin disk. I'll show the complete the workout. Okay, see once. Okay, no, so this field due to ring, field due to uniformly thin charged disk. These are the formulas you have to memorize. Make a habit of remembering things.